Hi, there's Professor Monty. Let's look at a general strategy for factoring. Okay, so we need to factor something. So here's the process we're going to go through. First, we're going to factor out any greatest common factor. Second, we're going to count the terms. If there's two terms, look for the difference of squares, the sum of cubes, or the difference of cubes. We have formulas for all those that we can use to simplify things. If there's three terms, it's a trinomial. We're going to use one of our methods for factoring a trinomial. Either, just the trial and error, two things multiply this, add to that. Maybe if there's a lead coefficient, we'll use the illegal move method or the AC method. I have videos on how to do all of those. You may want to look back to refresh yourself. And then if there's four or more terms, we're going to use grouping. Okay, and I've got a video on grouping too if that helps out. Okay, let's look at a couple examples. I start off and I say, okay, factor out the greatest common factor. So I look at all four of these terms and I'm like, well, they don't all have x's. I can't factor out an x, but 5 goes into all these numbers. So I'm going to factor out a 5. That's my greatest common factor. Leaves me with x cubed plus 3x squared minus 2x minus 6. Okay, now, no greatest common factor in there. I count the terms. I say there's 1, 2, 3, 4 terms. I'm going to try to factor by grouping. So remember, I grouped the first two and the second two. This 5 is just kind of out here for the ride. In each group, I factor out the greatest common factor in each group. In this group, I can factor out an x squared. It's going to leave me with x plus 3. This one I can factor out at 2. It starts with a negative, so I'm going to factor out the negative 2. Well, negative 2x divided by negative 2 is x. Negative 6 divided by negative 2 is plus 3. And remember, in grouping, if these are the same, I can factor that out. If they're not, I can't factor by grouping. Maybe I took out a minus there and forgot to change that to a plus. That's often a mistake we make when we're doing this. But now inside this bracket, so the 5's still out here. Each of these has an x plus 3 I can factor out, leaving with an x squared minus 2. That's my answer. The bracket I don't really need. Maybe I'll rewrite without the bracket. Now, one place I want to be careful here is this last term, the x squared minus 2. It still has an x squared. There's two terms. I can look for the difference or the sum of cubes. If this was a perfect square, because this is a perfect square, minus if that was a 4 or a 9, some perfect square, I'd have to go one step further and factor that as the difference of two squares. Okay, but it's not. Remember, the sum of squares is prime. That's why a squared plus b squared is not up here. Okay, this one's one that authors like to put into books because it's a difference. It might be the difference of squares or the difference of cubes. Oftentimes, if we go to the difference of squares first, it's going to make it easier for us to do. So if I can see this as something squared minus something squared, I can do it, and in fact it is. It's a cubed squared. That's 8 and 6. Remember, we multiply. And this is b to the third squared. So it factors as the difference of two squares. Remember that formula. A squared minus b squared is a squared minus b squared. So what I do is, I think I said that wrong. If I have something squared minus something squared, I use the first with a plus, and then the second. And then I do the same thing with the minus. I can FOIL that out. I'll get this. But this is the sum of cubes, and that's the difference of cubes. That's two more formulas. I'm just going to go straight to the formula. Remember, it's a plus b, a squared, opposite sign, same sign, opposite sign, ab, plus b squared. That's this first piece. And this one factors into a minus b, and then a squared plus ab plus b squared. All right, if you're having trouble on this one, go to my video where I talk about factoring the sum and difference of cubes. I think that'll help you out. That is completely factored if there's no greatest common factor in these. This trinomial is always prime from the sum of cubes or the difference of cubes. All right, so anyway, try this out, practice it. It's just a general strategy for factoring whatever you need to factor.